Google's Quantum Advantage Explained. Introduction. Today we analyze the Hindu article titled "What is Google's Quantum Advantage Leap?" In October 2024, researchers from Google, MIT, Stanford, and Caltech published 2 papers in Nature, announcing a major breakthrough: a verifiable display or quantum advantage using Google's new Willow quantum processor. In simple terms, it means that a quantum computer has successfully solved a problem much faster than any classical supercomputer. How does a quantum computer work? Think of how waves in a pond combine, sometimes amplifying each other, sometimes cancelling out. At the quantum level, particles behave like waves. A quantum computer controls the interference between these waves, amplifying the probability of correct answers and cancelling wrong ones. This is the foundation of quantum computing. It works with quantum bits, or qubits, that can exist in multiple states at once, unlike traditional bits that are either 0 or 1. In the new experiment, Google's team used a quantum algorithm called decoded quantum interferometry, or DQI, to solve optimization problems, that is, finding best solution among many possibilities. The algorithm used interference patterns to strengthen good solutions and suppress bad ones, completing the task in hours, whereas classical computers would take years. What is scrambling? The second experiment studied how information spreads or becomes hidden in a quantum system, a process known as scrambling. Imagine dropping blue dye in a swimming pool. Initially, the information is local, the dye is right here. As it spreads, every molecule carries a tiny trace of that information, but it becomes impossible to pinpoint. Similarly, in a quantum computer, data from 1 qubit spreads across all qubits through interactions. Google's team developed a clever way to rewind these interactions, like reversing an echo in a warehouse, to measure how deeply the information had been scrambled. This experiment helped verify that the quantum system was truly processing data in ways a classical system cannot. Proving quantum advantage? The Willow processor completed a simulation in 2 hours that would have taken the world's second fastest supercomputer over 3 years. That's a clear computational advantage. However, experts note that while these results are verifiable, they are still laboratory demonstrations, not yet real-world applications. Key challenges remain: reducing quantum errors, increasing qubit stability, and scaling to thousands of reliable qubits. Future breakthroughs may impact physics, chemistry, and optimization problems, including materials design and cryptography. Conclusion for UPSC aspirants: this topic connects to GS Paper 3, Science and Technology, covering quantum computing, innovation, and emerging research collaborations. Google's Willow processor shows that quantum advantage is now measurable, but turning that advantage into real-world solutions remains the next frontier.